It's way too hot in my garden shed, so I decided to do something about it.
Hello Internet, I'm Guy. About 20 years or so ago, I built this shed onto the side of my barn. Two reasons I built it. One was to support the solar panels at a nice south-facing 45-degree angle. I'm at about latitude 43 here, so that's an optimal angle for solar panels at this latitude. But also I wanted to have a garden shed. What I'm talking about today is a little project I did to make a little solar-powered, you see that little small solar panel there? A solar-powered ventilator to suck the hot air out because it gets miserably hot in that shed. And now I'm storing my cordless electric lawnmower in there. I don't want the batteries to get unrealistically hot. It could damage them, I'm not sure. It's just uncomfortable. And so I thought, okay, I'll just put this solar-powered ventilator in there and make a fun project out of it. So listed in the links below will be the source of the solar-powered ventilator and also a small digital thermostatic controller that I'm using because I don't need it to run in the winter, and it's handy to know what the temperature is in the shed there. So inside my workshop there's a display that I've mounted for the digital thermostat that shows me what the temperature is inside the shed, and it's set to trigger on at 80 degrees Fahrenheit and then off at 80 degrees or 2 degrees below that. I'm sorry, there's a hysteresis of 2 degrees. So let's look at what's inside and let's look at what's in my workshop, and you can see how I set it all up. So going on into the shed here, if we turn around and look up over here, you can see the ventilator right there. Let me just focus a little bit. Oh, there we go. So that wire there's a switch on it, and that wire tangled up over there goes through the wall. So inside my workshop you see all of the electrical connections for my solar panels, which will come down into that 240 volt panel right here, and then that feeds into the main panel and provides power for my two buildings here. But you look up over here, and mounted up near the ceiling is the small digital thermostat. Focus, there we go. It's reading 88.8, which looks like it's broken, but that's fine. You'll see a small glowing dot on the right, and that indicates that the thermostat has been activated. So it's pretty simple to hook this up, but I'm going to give you a diagram and show you some of these parts more closely.
So here's the diagram of what I put together. Now, if I didn't use the thermostat, you could simply install the panel and the fan together and just plug and play. That's very simple. It actually does have a plug right where the word switched is in my diagram. But what I did, of course, was basically splice the power wire, the red wire, through the switch in the thermostat, as you can see there, so that if the temperature gets too hot, that thermostat turns on. And it's a very simple hookup to do. When I first installed the fan, I just used a couple of screws and screwed it right onto a 2x4. The drawback of that is the noise of the fan would actually conduct through the wall and into my workshop and sounded kind of annoying. So what I did was I drilled out the holes in the fan and put in a couple of rubber grommets, both on the front surface and also on the back surface that nearly touches the 2x4 in the back. And that made a huge difference. I deliberately oriented that small solar panel to face southwest to provide optimal power in the late afternoon. That's when it's going to be hottest in the shed. What's interesting, of course, is when the sun goes down, there's no power to power the thermostat, so it basically shuts down, or turns off, if you will. And then in the morning, of course, there's enough light to power the thermostat long before it needs to switch on the fan. In this warming world, I hope you find this useful because it's not going to get any colder.